We have the integral from 1 over u squared plus a squared with respect to u. So in this case, u is our variable, a is going to be a constant, and it is equal to this particular value right here. And we want to talk about why that's going to be the case. So the way we approach this is obviously some memorization, but really it comes from trig substitution. This I talk about many times, that whenever we're dealing with some variable squared plus a squared, we're going to go ahead and create our right triangle, which we have right here. We're going to go ahead and make that theta. And because we have the variable squared plus the constant squared, we're going to go ahead and make our opposite our u, and then the adjacent side is going to be a. Through Pythagorean theorem, we can say that this hypotenuse is the square root of u squared plus a squared. Now we have to talk about the trig substitution that we're going to use. In this particular case, because I did this combination of opposite over the adjacent on this one, we have the variable squared plus the constant squared. We're going to go ahead and use tangent theta is equal to the opposite over the adjacent. So u over a. But if I multiply the a to the other side, then I get a tan theta is equal to our u. Okay, perfect. So now let's go ahead and find our differential. We're going to go ahead and take the derivative of this. This is a secant squared theta d theta is equal to du. So we have officially found the value that we're going to go ahead and plug in for our differential, which is going to be up there. All right, well, we need one more thing. We need to find the value that represents this right here in our triangle. I see hypotenuse and I see adjacent. I'm thinking secant. So secant theta is equal to the square root of u squared plus a squared over a. But if I move the a to the other side, I'm just going to have a secant theta is equal to root a u squared plus a squared. Gives me a squared secant squared theta equals u squared plus a squared. Perfect. So we have officially found the things that we're going to go ahead and use to rewrite our integral. Now we have the integral of 1 over a squared secant squared theta of a secant squared theta d theta. And look what's going to happen. The secant squares cancel out, which is really nice. There's an a on the top and an a square on the bottom. So one a on the top is going to cancel out, and then we're just going to be left with an a on the bottom. So this becomes 1 over a d theta. This will just simply become 1 over a theta plus your cheese. Well, we have to go ahead and start rewriting this in terms of u. So we're going to go ahead and look at this right here. We have tan theta is equal to u over a. So we can say that theta is equal to tan inverse of u over a. And at the very end, we have that the integral that we were working with, which was this right here, is now going to equal to 1 over a times the theta, which we found to be this expression right here, tan inverse u over a plus your cheese. So again, this is something you got to remember. A lot less work to do if you just memorize it, but here's the work behind it.